So it's Thursday, which means happy garbage day to those of you who are celebrating garbage day on the other sides of town. I'm going to start the screen share too. How about that, Zoomers? Several days in a row I did not screw that up. Turning a corner. So I spent the morning working on your next homework. It's not available yet, but we're getting there. It will be based off of what we're talking about now in terms of adding random slopes and cross-level interactions. I posted on the course website the answer key to the formative assessment with respect to what the code should look like, as well as an equation describing the model itself. So let me know if you have any questions on that. I have lecture 4, slide 24 in front of me to remind us what we were talking about before, right? Should we back up a little bit more? Let's back up to a picture. I like pictures better than words. What's a random slope?
It's a level 2 thing.
It is a level 2 thing.
I have that part down, so.
Yep.
I know you want more.
I do. What's a random slope? We know what a fixed slope is, right? You probably didn't call it that, but a slope is just the change in y for a 1 unit change in x. Fixed slope means the kind that everybody gets. All cases in your data set have the same slope, the constant. What's a random slope then?
Like you allow different groups to have different relationships for that set of variables.
Yes, different relationships captured by the slope. So where each cluster, in this case, or group if you want to call it that, would have a different slope, conveying the level 1 relationship between a level 1 predictor and an outcome. So the idea is that a person relationship, the strength of that relationship varies across clusters. So we can estimate a variance for the slope deviations, the idea that some clusters might have a stronger relationship of that person predictor and that person outcome, and some clusters might have a weaker one. So it is a level 2 thing, but what the slope refers to is a level 1 relationship. That's where the trick comes in. It's a variance across level 2 units in a level 1 relationship. Yes or no?
Yeah.
Yeah, it is. Cough, cough, homework question with bad distractors.
See, you say bad distractors though, but like sometimes, like maybe if you haven't read enough or if you don't know all of the synonyms, it's like, yeah, I mean, that seems logical.
Some of the distractors are just incorrect, which is why I mean they're bad. So some of them are closer to correct than others. But it is a level 2 variance across clusters in the extent of a level 1 relationship. That is what a random slope is. It also means that we're saying clusters differ from each other systematically in 2 different ways. We have their mean on the outcome, which would be like the y-axis in this picture, and the strength of their relationship of this person-level predictor. So clusters have 2 different piles of variance attached to them. We can predict each pile using different fixed effects. What type of relationship would explain random slope variance? What do we need to do to capture that additional source of variation? It's a special kind of slope. Yeah, cross-level interaction. That's what explains random slope variance. And it has to be an interaction between the level 1 predictor that the random slope is for. So like in this picture, I have this generic within cluster X. It would be an interaction of within cluster X with some kind of cluster characteristic. Why is it that some clusters have a stronger relationship of this person thing? Because of something about the cluster. Some kind of level 2 predictor. And that could be either a cluster characteristic that's measured that way, such as like rural versus urban, or what type of process is happening at that school, or it could be the aggregate of a level 1 predictor. The average state, for instance, of X could be a level 2 predictor that accounts for random slope variance. So the short answer, when you put in level 2 predictors by themselves, what are they for? What kind of variance do level 2 fixed effects explain by themselves, like main effects?
Like kind of like the differences in intercepts.
The differences in intercepts, otherwise known as random intercept variance. Yep. And so interactions of cluster things with person things explain random slope variance if the person slope has a random slope in that model. How about level 1 predictors? What kind of variance do they explain? It's kind of a trick question.
Level 1 things
Level 1 things,
between person, like why some people do better than other people.
yeah, why some people have different outcomes. Yep. But level 1 predictors are almost always level 2 predictors too. And so that part of it can also explain level 2 random intercept variance. Question, would it be correct to say that level 2 fixed effects describe variance in cluster-specific expected outcomes? Yes, I would say that sounds correct to me. Does that sound correct to you? More or less? I think so. So this is the new idea, the idea that level 1 relationships can vary across clusters just as the expected outcome does, and inserting cross-level interactions in the model to be able to explain that random slope variance when it shows up. So this was the story that we had before. I have both versions of my level 1 predictor. Constant centered is attached to beta 1, cluster mean centered attached to beta 2, because we are giving a random slope to the cluster mean centered version. Do you remember why that is? Why it has to be that way? Why is it that I need to do this kind of crazy looking model where the random slope goes with the cluster mean centered version of the variable, but the fixed slope doesn't have to? Answer, the slopes are different in clusters? What do you mean by that? The Zoomers are typing to me. You got gestures lined up here?
Well, so last time, for the highlighted part, I
Mhm.
think this is where my note was supposed to go. I have it smushed, and you need a contextual interaction to unsmush it.
That is true for this right here.
Okay.
That is true. But I'm actually one step behind that,
Ah, okay.
which is why do I have U2 attached to a separate variable? What would have happened if I would have attached it to the constant centered version instead? Squish. Yeah, it's the same type of problem. The random slope would multiply both the level 1 part as we want, but it would also multiply the level 2 part, which we don't want. So we got to take it out. So that's why it needs to be this version for it to be actually representing cluster differences in the within cluster effect of some person predictor. Has to be the cluster mean centered version. So that's why we have this sort of weird looking model, which is known sometimes as a hybrid model, because you have a constant centered fixed effect and cross-level interaction with it, whereas we have a cluster mean centered random effect. Looks a little weird, but it solves the problem. I would do it this way if I were interested in getting contextual effects at level 2. That's the purpose of this model. Otherwise, if I use cluster mean centering for everything, my level 2 effects would be between instead. And for one more review on that, what's the difference between contextual and between?
Contextual is like the difference relative to your cluster.
Contextual is the difference relative to your cluster?
So like, never mind.
No, I think you were on the right track.
I may have been, but I would need more minutes to,
Need more minutes?
and a strange arrangement of words in order to get there.
Okay, fair enough.
Contextual is between minus within?
Yes, that is also true. Within plus contextual is between minus within is contextual. Those are all true things. All right, we have Kendall, do you want to talk?
Yeah, is it the effect of clusters after controlling for within person information? So like,
Within cluster, but yes. You
Wait.
said within person, that's the other class.
you know what I meant, yeah.
I did, say it again.
The effect of clusters after controlling for person level information.
Exactly right. A contextual effect is the incremental extra effect of the cluster after controlling for the effect of the person information. That is correct. A between effect does not control for the person information. That's the difference. Any one model will only give you two slopes. You can get the third as a linear combination, and that's where the within plus contextual equals between, or between minus within equals contextual. All right, how we doing? Hanging in there? Thumbs heading towards up? Take the derivative of the thumb function. Is it positive yet? Excellent. All right, so here's the fun part here. Can I put this cross-level interaction in here to explain random slope variance? Even though it's in a different equation, it means the same thing, because this fixed slope right here is the within slope after controlling for the contextual effect in the model. So what this is supposed to mean is that the within school effect of being stronger in verbal than your peers depends on whether your school has mixed grades or not. And that cross-level interaction is supposed to explain part of the reasons why schools differ in the effect of relative verbal ability. So the purpose is to explain this new random slope. But because of the way the model is set up with respect to the fixed effects, this is a smushed interaction. And that's what you wrote down. Question?
The interpretation of this to me is weird
It
because
is weird.
in this case the random slope would be reflecting the variance of the between part, the effect of our level 1 predictor across clusters, but that's the between part. However, the fixed part would be reflecting what's the effect of the cluster mean after controlling for the level 1 predictor. But for example, if we would like to use that random variance to create some kind of confidence interval, we would be using the contextual fixed effect. Could we do something like that, or should we change our contextual for the between to use the random part that we are calculating for that fixed slope?
Okay, I think I understood the question, and this random slope is applying to the within effect, not the between.
Oh, yes.
So that's why it makes it okay to use gamma 1O as the middle of that interval and compute the variance around it using this, even though they're part of different equations, is because what it means is the same thing.
Okay, yeah,
Because this is the within slope
yes.
after controlling for the contextual effect. That's the connection.
Okay, okay.
So you can think of this beta 1 and beta 2 really as all one equation in terms of what it means conceptually. It's just that to get there correctly, you have to attach the random slope to the cluster mean centered version so that it's not multiplying the between part as well.
Awesome, yeah.
That's the
Great.
connection. So yeah, we can lump these together for all intents and purposes and talk about it that way. So mixed grade is supposed to explain part of the reasons why schools differ in their effect of student verbal on student language performance. That's the idea.
Yes, yes, you are correct. However, now we know that random effect, that variable that we are using is considering 0 as the variable centered at the cluster mean. However, the level 1 variable we are using can be centered at any point,
Yes,
even less than center.
yes.
If we would like again to construct this confidence interval, what 0 would be in that case?
The confidence interval around the slope,
Yes.
the middle would still be gamma 1O
Okay.
because that's the average within effect, and then U2 would be the offness for a given cluster, and the variance of the U2s across clusters would provide the range around the fixed effect.
Got
The
it.
square root of the variance, I should
Got
say,
it.
standard
Thank you.
deviation. Yes. Yeah, a lot of words to this, huh? That's what makes this really hard, I feel like, is like the connection of ideas and math and language. So this, by the way, is not okay. It is the same problem as when we entered a level 1 predictor without unsmushing it. It's the exact same thing. It's just harder to see. What this is saying is that, this is where we got to last time, that the within effect of verbal is moderated by mixed grade to the same extent that the between effect is. Because we're lacking a contextual effect to make sure that this interaction applies only to the within part. Okay. Can I give you a more simple general rule to follow?
All for it.
All for it. Here's your guiding principle. When you have a constant centered level 1 predictor, okay? When you have a constant centered level 1 predictor, meaning it still has all the level 2 stuff in it, you just change what 0 means. Anything that you do to that predictor, you need to do to the contextual effect that goes with it too. That's the rule. Let me get out, not Paint today, we're gonna go in Excel.
Whatever you do needs to be done to the contextual.
Yep. Yeah, this is me drawing on the board so that the Zoomers can see it. Okay, so we have, let's say here, we have within, let's go. Verbal -10 is my level 1 predictor. And if I put that in the model all by itself, so we'll say level 1 only, what kind of slope does it have? If I just put a level 1 predictor in the model,
Smushed.
it's smushed. What does smushed mean? More formally,
We are constraining between and within to be.
it's saying smushed, let's do it this way, within equals between in terms of the relationships here.
Can't, because they're supposed to stay in their own lanes.
They need to stay in their own lanes, exactly. Another way to say this exact same problem,
No context.
no contextual effect. Those are two different ways to say the same thing. Because context effect is between minus within. If between and within are the same, then you get 0 when you minus them. Yes, I know it's called subtraction, but I have an 8-year-old and we talk about plussing and minusing as verbs. So,
Approved.
yeah, it's fine. So this is a problem, right? This is assuming that your context doesn't matter. It's assuming that the effect of being in a site that has more of this characteristic is the same as being a person that has more of this characteristic. And within and between coefficients are on different scales mathematically. They are unstandardized coefficients that all depend on what a unit is of x and a unit of y. So unless you have ICCs that are 50-50, like they're not going to be on the same scale. So there's a lot of reasons why this will not hold in real data. So how do we fix it?
Needs to be the 2 variables.
There needs to be 2, so keep this one.
What's our other variable?
I would call it like CM verbal,
Okay.
something like that, centered at 10. So if I do that, what does the level 1 slope become? Is it smushed anymore or is it okay now? What does it change into? Within. What's that guy? Other one,
Contextual.
contextual.
Okay. So cluster mean equals contextual.
If it's paired with the original level 1 predictor that still has the level 2 stuff in it.
So as long as that, so it couldn't be like CM mixed grade and still be contextual. It would have to be CM verbal.
So CM stands for aggregating the level 1 person information up to the cluster.
Uh-huh.
Mixed grade does not need aggregating because it's already level 2.
I gotcha, I guess. So, but it has to be the same variable. Like it couldn't be like cluster mean student or something.
Yeah, okay, I think I see
Yeah.
what you're saying. Yes, it has to be the cluster mean of that verb, of that predictor specifically.
To be the contextual, yep, okay.
And that is also why, even though we deal with proportions for binary predictors, and proportions get weird because then a unit change is going from no characteristics to everyone has that characteristic, I keep it in that scale, otherwise this relationship gets screwed up. Now, what you're thinking of, I think instead, is this becomes between if I change out what the level 1 predictor is. If I change that one into within, then it's within between. This is the cluster mean centered version. So putting it together, if you have your level 1 predictor, still has all your cluster info, and you introduce the cluster mean to unsmush it, that cluster mean is your context effect. The extra component of the mean that's not already contained in your original level 1 predictor. So the context effect is controlling for the person effect because all the person information is still right there to be controlled. The between effect is not controlling for the person information because we took it and made it relative only. Within cluster centering changes it to relative to your cluster, whatever that is. Okay, how we doing?
There's
It's a little painful, I know, we're getting there, we're getting there.
chuckle because I've probably written this down many times and just so many matrices where I'm like, okay, but then still I'm like, not quite.
Yeah, I haven't even gotten to matrices yet. Let's see, we have a question from the chat, and then I'll go to you. Within cluster verbal is subtracting off the cluster mean instead of 10, correct? Yes, that is correct. That's why there's no 10 here. That's not a typo. I don't put the 10 here because it's not centered at 10. It's centered at the cluster mean, whatever that happens to be. Okay. And then, did you have a question?
That was my question.
That was your question. Okay, excellent. Yeah, the labels are like very deliberate. And I used to, Nikki and I talked about this after class. I used to not say cluster mean, I used to say like between as the name of it, but then that would screw people up when it became a contextual effect and not a between effect. So we're sticking with cluster mean because what it means depends on what it's paired with. So these are two different ways to get to the same result. Either way you get the within slope at level 1, what you get at level 2 varies. Okay. Now what if I'm interested in moderation of my verbal effect? So if I come back up to this model right here, I'm going to add in, actually no, let's go right here. Change my mind. There we go. We're going to need some more rows though. Okay. So now I want to add in verbal minus 10. I'm probably going to need some parentheses or Excel is going to yell at me. Actually, can I just call it verbal 10? Are you okay with that? Okay, there. Now what if I want to do that times, I don't know what, some kind of level 2 predictor. So I'm asking, does the extent to which relatively more verbal matter, does that extent differ by a function of some site characteristic? Like whether the school uses mixed grades, for instance. Since that's it, I'll just put that in here, mixed grade. Okay, so this interaction does not have a corresponding level 2 part. So just as we had up here, it's a smushed interaction as well. It's the same. So we fixed it before by adding a contextual main effect, right? How do I fix it now? I need a contextual interaction. Do the same thing. That's the rule. Whatever you do to the level 1 thing, you got to do to the level 2 thing. That's your rule. So if you want to have the effect of within verbal vary by mixed grade, You gotta let the contextual effect of verbal vary by mixed grade. That fixes it. So then this becomes within by mix. This becomes context by mix. Can you guess how I would get to between by mixed? Add 'em up, add 'em up, up.
Yeah.
Yeah, it's the same. What if I want to know if my effective student verbal varies by how much verbal my school has? Does the effect of being smarter than everyone else depend on how smart everyone else is? That's like a frog pond kind of thing. Verb. Close.
I think
That's
we
a
just
weird
roll
one.
with it.
Uh-huh, and you can see where I'm going maybe. This is gonna blow your minds. Okay, is this all right or not okay?
No, yet.
No, we need to.
We need to disentangle the
What's the rule?
do the same.
Whatever you did to level 1, you do to level 2 too? What do I need to fix it?
A quadratic effect.
Uh-huh. CM verb 10 by CM verb 10.
But,
Uh-huh.
Now
is that the
that's
same
a-
thing?
It's a quadratic effect. So this is where it gets a little bit weird when you have, I would call this an intra-variable cross-level interaction. It's between the two halves of the same variable. You end up with, you need a quadratic contextual effect to unsmush it.
Huh.
Mm-hmm. Do the same thing. That's your rule. Whatever you do to level 1, you gotta do to level 2. When you have this setup, otherwise you're assuming that whatever you just added is the same within as it is between. That goes for main effects, that goes for interactions.
Lisa, should that on 9, should it be verbal 10 or is that a different variable?
It should be verbal 10, thank you. Yep. So this is a more,
Making sure I
go ahead, I'm sorry.
just making sure I didn't miss something there.
No, yeah, and when you name things in your life, be consistent, right? This is where it gets, you can get into trouble real quick with like, a lot of people when they name new variables, I see this a lot, like, this is the centered version. That is no longer specific enough. Right, is it the level 1 or the level 2, and what is it centered at? Like, these are all choices. Do I have a possibility for cluster mean verbal? Can I cluster mean center that, or do I have to constant center that? If I'm talking about a level 2 cluster mean variable. Can I do cluster mean centering on that?
Why not?
Why not?
Well, so what's the?
So you have a choice when it comes to level 1 predictors, which one you want to put in the model.
Right.
Yeah.
Okay. I'm asking, does the same choice apply to level 2 predictors? It
No,
doesn't.
because that's the cluster mean and that's all, right?
Yeah, so it already is up at the cluster. Like, you can't within cluster center it because there's no within variability. So it just has to be constant centered at level 2. So level 2 predictors only need to have 0 as something meaningful. They only have level 2 variance. The goal of cluster mean centering is to remove the level 2 variance out of the level 1 predictor, leaving just the within information. This one hurts. But it's a quadratic effect of the contextual effect. So that would mean that the effect of the context could like get stronger as you move up the variable or weaker. Like if you picture a quadratic kind of bendy line, that's what you'd be creating. And yes, I have an example of that. Because it's hard. What if I did it this way instead? This is the way that I think is generally easier to keep track of. So let's say that I did within verbal here by mixed grade. Is that smushed or is it okay?
It's
Okay.
okay because it's just within.
Yep, this is just within by mixed. How much does the within effect depend on whether your school uses mixed grades? Do I have to have the corresponding one?
If you want to, when
What would this one be?
between.
Yeah, between by mix. So do I have to have it? No. Does it make sense to have it? Probably. I think it's a reasonable question if you're going to allow part of a variable's relationship with an outcome to vary as a function of something else, that you let the other part vary as a function of something else too.
And if we do the same thing to each level, don't we have to do it though?
Only if you're in the world of constant centered level 1 predictors. If you're using constant centered level 1 predictors, the rule is whatever you do to it, you do to the level 2 part 2. That prevents smushing. Otherwise, if you leave something out in cluster mean centered land, you're not having to worry about smushing because it's just, they're staying in their lanes. Okay. You want to see some math?
I mean,
No.
maybe.
Some numbers, I mean? Yeah, I'm not doing the math right now. We're not there yet.
You can just, I'm just thinking through studies and you can just see all the areas things can go so wrong.
Yep, things can go sideways. And honestly, the smush cross-level interaction thing is not well understood. Even less well understood is the quadratic thing. I have run into methodologists being like, why did you add the squared term? I'm like, I have to. So, okay. So that's how we fix it. Whatever we did to verbal 10, we got to do to its counterpart, the cluster mean centered version. So to unsmush it, we add in that term right there. So now mixed grade is multiplying the within part and it's multiplying the contextual part. So I've got definitions here for all the things. Let's look at an example so we can put some numbers on there. This, by the way, I added to the models that I had used in the APA workshop to demonstrate these points. So I made a revised version of the download and posted a link to it here. So this is extra content relative to what I had time to deliver in 2 hours.
But very well done in 2 hours.
In 2 hours, yeah. And now you all understand why I think that workshops are not the way to learn something really thoroughly. You just can't. All right, so here's the right answer in terms of making sure that everything is properly distinguished across levels with this new cross level 2 interaction is what I would call it, not cross level, because it is entirely using cluster characteristics. So we have then, let's see if we stick with just the verbal stuff here. So verb 10 here, that number, in this model, what does that mean? Within, contextual, between, or smushed?
Within.
That's within. So for every unit more verbal I have than my school, my outcome goes up by 2.4. Am I done with the sentence or do I need to keep talking?
Keep talking,
I got to keep talking. Why do I keep talking?
because now that slope is conditional on the other variable at 0.
Yep, so it's conditional on mixed grade being 0. So it's conditional right here. The only time that I can say the within effect is given just by verbal 10 alone is when this part drops out, which happens when mixed grade goes to 0. So putting it all together, 2.4 is the within slope for how 1 unit more verbal ability than your peers translates into a different outcome. It's higher by 2.4, specifically in schools where mixed grade is 0, meaning they don't have mixed grades. What would the verbal slope be in schools that do have mixed grades?
More positive.
More positive by 0.34. So the rules of interaction still apply no matter what kind they are. Interactions take their constituent main effects and make them more positive, less positive, more negative, or less negative. And that's significant. How about that? Now this thing, that one, other interaction goes with the contextual effect here. So cluster mean verbal centered at 10 has a slope that is also significant, 0.83. Anyone feeling brave want to try that in a sentence? 0.83, that's the number we're focusing on here.
So within the cluster,
This is cluster mean, so we're talking across clusters now.
so across clusters, for every additional 0.8255 units of verbal,
Other way.
units of,
Yeah, it's 1 unit of verbal. It translates into
oh,
point.
yeah, for every,
Yep.
yeah, 1 unit of verbal, you're gonna do 0.8255 better? Or
Yes.
What?
Okay,
Something like that?
that's something like that.
It is better, it's a net positive.
Yes,
but-
because better language is good
yeah.
in this world.
As clearly demonstrated by
Yeah,
that explanation.
not that I would know,
Yeah.
right? I tanked my GRE verbal, but who cares? I'm here to show for it. Okay, so this is a cluster thing, right? Cluster mean, you want to give it a try?
Yeah, so for every 1 unit increase in verbal, for every 1 unit increase in cluster mean verbal,
Yes.
the outcome, which is language, increases by 0.825.
Yes, the story is that this is like a standardized test of like language achievement, whereas this is like language ability. So they should be related to each other. So yes, your cluster, for every unit more verbal you have on average in your cluster relative to other clusters, the whole cluster's outcome goes up by 0.83. Is that the end of my sentence?
Well, it's not significant, but I guess, I don't know if that's what you're.
It depends on what you're judging alpha at, but is that the end of my sentence, though, is the question? No.
No.
Is this conditional?
Yes.
Yeah, it's conditional on the interaction. So this is the contextual effect in schools that don't have mixed grades. What happens to it in schools that do have mixed grades?
More positive.
More positive.
Wait,
Non-significantly, but more positive.
no,
The second interaction term.
right, but isn't 0.4 lower than 0.8?
So this is the main effect of the predictor when mixed grade is 0. The interaction term tells you the difference in that slope for a 1 unit change in the moderator. So the 0.83 goes up by 0.4 if you're talking about a school that does have mixed grades.
Oh, okay,
That's
that makes sense.
it's a difference in slope. An interaction term is always a difference in slope. And if I wanted to know how the between verbal effect varied by mixed grade, can I figure that out from this model, even though none of these is between effects?
Yeah, but then
Yeah.
you add them up.
Add them up, up, up. That's right. Add these two up. That gets you to your between interaction. So if you had to guess, and you actually don't have to because it's in front of you, but it's not in front of me yet, what do you think would be the coefficient for this cross-level interaction if it were smushed instead? You think it'd be
Something close to 0.33.
something close to it, but do you think it's going to be higher or lower?
A bit higher.
Think it's going to be a bit higher? Why is that?
It's more, it wasn't stripped out, so there's more in there.
The level 2 part is still in there. Survey says a little bit higher.
Yeah,
It's biased. So this is both how the within effect of verbal varies by mixed grades and how the between effect of verbal varies by mixed grades. We know from over here that the between effect should be 0.33 plus 0.41. So this is being pulled a little bit too high because it has that between assumption as part of it. But it is very close to the cross-level interaction over here because most of the information in this model is at level 1. It's pulling it that way. Okay, yeah. And if this is making your head hurt to sort out contextual and between and smushed, I got a remedy for that. Cluster mean centering for everything. Then what you have is within between, no matter what. You can get contextual is the difference. The cross-level interaction is unsmushed regardless of whether you have the level 2 counterpoint, because it's involving only the within variance of the level 1 predictor. So you don't have to worry about that. The level 2 interaction talks about how the between effect differs, and you can get to the implied contextual level interaction as the difference. Okay, general principles. Within plus contextual equals between. Between minus within is contextual. And if you're in a constant centered level 1 model, whatever you do to that, you got to do to the level 2 part 2. Those are your rules. Yes.
So, maybe it's obvious, but where's Y05 through 9?
Where is what? I'm sorry?
So in our notations,
Oh.
like where's Y05 through Y09?
Okay.
Well, those aren't like in a row necessarily, because the first one is talking about like what you're attaching it to. So like the gamma 10 is being attached to that particular beta right there, the beta 1.
Yes, I think I understand the confusion. So this is not counting, like this is not beta 10. This is 1, meaning it's attached to beta 1, and that's why this one starts at 1. It's more like it's like a grid system.
I got you.
The
That
first number gets you to the right beta, the second number gets you to the right place in that beta equation. And that's why if you're going to have 10 predictors, like you might have to start putting commas in or something, because otherwise it breaks it. Yeah, I've seen that. And we don't have an 01 because I had another variable for homework that I kicked out of the story like several slides ago. And so that's why I'm skipping 1 here, because 1 would be for the cross-level interaction of that missing variable with the cluster mean centered variable. So here's that version of the model where I switch what the level 1 predictor is, and then here's how you get back and forth. So on the left-hand side, on slide 31 here, is what the model would tell you directly if you used constant centered verbal at level 1. So your whole model is phrased in terms of within and contextual. On the right is if you swap out that level 1 predictor and use the cluster mean centered version of it instead, then your whole model is phrased in terms of within and between. So let's go down the list here. Intercepts, same or different? Same. Either way, this is the expected school mean outcome for schools that I have homework made it back into this one for whatever reason. I thought I kicked that out.
At 2, I think.
Yeah. Well, it's not significant. It's not part of my story anyway. It's not part of this because it's not interacting with anything and it's a level 2 predictor, so it's fine. Whatevs. Mixed grade is also a level 2 predictor, but it is conditional on its interaction terms. So that's the difference at the school level between schools that do or do not use mixed grades, specifically when you're at verbal 10 for a school that's at verbal 10. Let's go to the next one here, CM verbal 10. Same or different? Way different. Question is why?
Because it's the between, and it's got the contextual from the left and the within from the left combined into one.
Exactly right. 3 is 0.8 plus 2.4 here. So on the right, this is the between slope, which is within plus contextual. So CM verbal 10 on the right is not controlling for individual verbal ability. CM10 on the left is controlling for individual verbal ability because that's still part of the level 1 predictor that is being partialed against.
So it would seem then that when in doubt, contextual it out.
I'm not sure about that. I think it depends on how you want to talk about your results, right? these are both two different versions of what people would consider a cluster effect. It's just do you want to control for the individual first or not?
Okay.
Honestly, it's up to you. I think the right side is easier to is easier for me to handle, but I'm not usually interested in contextual effects because I don't live in that world very much.
What would that world be?
Cluster data. I live in longitudinal data land. That's why. And the analog, if you have longitudinal data in which occasions are nested in persons, the contextual effect would tell you the effect of the person after controlling for the effect of the occasion, which is weird because an occasion is not a thing, the way that a person inside a cluster is a separate thing. I know, right?
Wait, can you say that again?
Yeah. I live in longitudinal data land most of the time. I have very little real-world experience with cluster data because I don't, this is the first job I've had in the College of Education where it was a big thing, to be honest. So in longitudinal data, occasions are nested in persons. A contextual effect would mean the incremental contribution of the person after controlling for the effect of the occasion. And occasions are not separate entities, the way that people are separate entities from clusters. So a contextual effect in longitudinal data to me does not make any sense. I don't see it as a useful thing. And there is no smushing problem if you use cluster mean centering. That's the other reason. Everything that you're leaving out is assumed 0, not assumed to be equal to something else. Okay. Verbal 10 versus within cluster verbal. Same or different results? These two.
Yeah, that's the same.
Yep, here we go. There they go. The same, even though it's attached to a different variable. So on the left, it is the within slope because we controlled for the contextual effect. We unsmushed it. On the right, it is the within slope, period. Always. How about the cross-level interaction? Which one is that? Second to last or last? Second to last, because that's mixed grade times the level 1 verbal. Same result or different? It's the same, because they both mean the same thing at this point after controlling for the contextual effect. On the left here, this is the extent to which the within effective verbal varies by mixed grade. That is exactly what it means on the right-hand side as well. But the only reason it means that on the left-hand side is because of this level 2 interaction that I've added. Whenever you do something to the level 1 part, you got to do it to the level 2 part if you're in constant centering here. And these, even though it looks like it should be the same, are different for the same reason that these two with cluster mean verbal were different. On the left, this is how the contextual effect varies by mixed grade. On the right, it's how the between effect does. But as you can see from the estimate statements, you can get to the missing one. Between minus within is contextual. Within plus contextual is between, and that applies to both main effects as well as interaction terms. So that one is right here. That one is right here. That one is right there. That one is right there. I'm the only one who's happy about this. Zoomers, how you doing? So which you choose is up to you. As long as you're not smushing things, it's fine. Probably for the sake of your readership, though, I would pick one strategy and go with that across all the variables in your model. That way some of them aren't within contextual and some of them are within between. I think that can get very confusing real quick. All right. The good news is that the model for the variance is interpreted the same way. So the intercept is all the reasons why school outcomes differ after controlling for mixed grade, cluster mean verbal, and their interaction. given the fact that we have a random slope that is specifically for children who are at their school's mean, because the random intercept is conditional on the variable that the random slope is for being 0. Does that make sense? Do I need to go back to Excel for that? Going back to Excel. I just decided it. Okay.
Excel sheet that will be posted on Icon later.
Well, if this is useful to you, then sure, I can post it. This is sort of like doodling, but I'm not an artist. I can only type. Okay, so let's say that we have the fixed side here, and we have a model that only has an intercept. What's the intercept mean? The average, right? What if we add, some level 1 x variable? Now what does my intercept mean?
What you get when your L1x is 0.
Yeah, so it's conditional on this. What if I add, I don't know, QT6? Now what's my intercept mean?
What you get when the other variable is 0.
When this is 0, when that's 0, right? Okay, watch this. Ta-da. Okay, these guys aren't here. What's a random intercept mean?
Just a specific deviation from grand mean.
Yeah, it's like a cluster mean deviation. And that's the end of the sentence, right? Just like when this stuff wasn't here, that was the end of the sentence. Your intercept was just the mean. Now what if I start adding some stuff?
No, that's the leftover random variance.
It's not left over because we added a new variance component.
Oh yeah, specifically for the level 1 predictor at 0.
Yeah, so now this is the intercept cluster mean deviation specifically when this predictor is 0.
Yeah.
It's the exact same thing. It's just that we're talking about random effect deviations of how far off your cluster is from what's happening on average, whereas fixed effects is what's happening on average.
So random is how far off the average?
Yes. Yep. So if I go back to, I want a picture. There. This one. So in the right-hand side, this is slide 23, we have a positive slope on average. The U random slope for the pink cluster would be a positive number because this slope is more positive than average. For the orange cluster, the U random slope would be a negative number because it's less positive, shallower. So yes, random effects are phrased as deviations from the fixed effects. Another way to say that is that the beta is the variable as a whole, the middle is the fixed effect, the randomness is around that. Not better, okay. All right, I withdraw the analogy. Not better. There. Okay. For the same reason that we talk about the intercept as the expected outcome when your predictors are 0, more specifically, predictors that have fixed slopes are 0. This is now when predictors that have random slopes are 0. So if this is my model, is my random intercept conditional on 0 for this? It is not, because it doesn't have a random slope. Each side has its own thing going on in terms of conditionality. So let me take this out here. So I would call this a random slope model because we have a individually cluster-specific deviation from the fixed slope represented as the random slope. What it's deviating from is over here. So I'm gonna put a gamma, help with tie in the notation here. And then this is a U. And I always make it a capital U because then it doesn't look like mu or some other letter that would be easily confused. So So I can do this just fine, right? Can I do this? Sure I can. What am I saying about the effect of level 1x if I do this?
Same across clusters.
It's the same across clusters. If I put it back, now what am I saying?
That the fixed effect differs across clusters.
Yeah, now I'm saying that these two combine to give each cluster their own slope. The average slope is here. How far off your cluster slope is over here. You put them back together again, you get to what the slope should be for your cluster. So fixed is what happens on average. Random is how far off your cluster's version of it is. Now, can I do this? I should not do this.
Yeah.
It will probably result in estimation problems. Because what am I saying if I do this?
Something is varying around nothing.
Yeah, it's varying around nothing. More specifically, I'm saying that. Your random slope is always how far off from the fixed slope. If the fixed slope's not there, you're saying the fixed slope is 0. We don't want to do that. So if you're going to add a random something, you better have the fixed something that goes with it. The reason why we can do it in the hybrid model is because by the time you end up controlling for all your contextual effects, this is the within slope on average, and U2 is how the cluster deviates from it. They're functionally one equation at that point. They just have to be multiplying different variables to make it work out that way. Okay. We did that, 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 we did that. Okay, that's where I was. Yes.
Can we pause for a minute and just let it sink in?
Yeah, I had a request to
Some
take a break.
processing
Right.
time.
All right, Vladimir, do you have a question?
Yes, because that U2, well, it is weird in multiple ways, but this thing, it is exactly the same value in both models, regardless of what level 1 variable we are using. The variance will be the same at level 2, right?
You have to use the cluster mean centered version that is given the random slope.
Yes,
But regardless of what's happening on the fixed side, you get the exact same variance
Exactly.
components out.
exactly. So the value is exactly the same. However, the interpretation is different. Why?
The interpretation of the random slope is not different. It's
Okay.
still how far off your cluster is in terms of its slope from the average slope. The
Yeah.
average slope is just given by a different physical variable.
Yes, but to me that's not what U2 says there. It says deviation of original from predicted level 1 within verbal slope for school C.
Yes, meaning that it's only deviating from just the fixed slope and not from any cross-level interactions that are modifying the fixed slope. That's what I mean.
Okay.
The idea is that it's all the reasons why the slope differs, not part of the reasons over here being explained with a cross-level interaction.
Yeah.
Yeah. You
Yeah.
sound sad.
Yeah, because I thought that we will have exactly the same definition that we have in slide 22 because it is the same variable, it is the same effect, but it's not the same words. That was weird when I was reading these slides.
Yeah, so 22 is what he's comparing against. In this model, which the non-composite version is up here, so this is the idea. Like, there's nothing else predicting the slope. So here's the middle of it, here's the deviation. So this is the baseline against which you would compare how useful a cross-level interaction is. Like, this is all the slope variance there is to be had. So then, after you add some stuff and try to predict it, U2 is like how far off you are still, but from the prediction given to you by the cross-level interactions, not just from the fixed slope, as one number.
Yes, great.
Okay, we're getting better,
Yes.
inching our
better.
way along.
Thank you, Lisa.
And E is differences that are left over between students after controlling for everything.
Okay.
So
But
this,
at this
go ahead.
point- But at this point, that's acceptable though, because we've controlled for everything?
Yep, after all
Okay.
the fixed and random effects, like everything goes in here. E is all the reasons why some kids are still have better outcomes than other kids, besides all this stuff. Not what cluster they're in, not any characteristics of the cluster, not any characteristics of themselves that are already in the model. These are other reasons why kids differ from each other that we don't know yet.
Do we ever get to know?
Only if you get an R square of 1. I can get pretty close to that in simulated data. Not ever in real data, though.
Okay.
So if this were my model, how many potential pseudo R squares could I calculate?
3.
3. Why do some clusters have different intercepts? Why do some clusters have different slopes? Why do some kids have different outcomes? So in terms of what explains what, all 3 of those things, what do they do?
Reduce random intercept.
Reduce the one in its,
I just said UOC.
yep, that one. Okay, what about this one? It looks weird, but it actually is U2. Because functionally speaking, this is really all one equation. It's specified weird, but you can think of it as one thing. What about that guy? The level 1 effect.
Residual variance.
Yeah, that's that one. Go ahead.
Yeah, but in this case, we would be comparing this model against what? That's not the empty means random intercept model because we have a random slope now. That's reducing our level 1 residual variance, but not explaining it.
Yes, so this is the point where my philosophy diverges from those of others. I'm going to give you my opinion. To me, it does not make sense to go back to the empty means random intercept model as your point of comparison. Because that is a 2-pile variance model. This is a 3-pile model. I don't think they're comparable. What residual meant before is not the same thing because part of what was in residual was this random slope variance. So to me, when you add a random slope, that forms a new baseline that you don't cross back into what's happened before. That can cause some weirdness though, because some of your predictors, you would compute effect sizes before that point and perhaps others after that point. So that's where it becomes tricky to describe it. Other folks do not make a separate R square for the slope variance specifically, and they lump everything back down into empty means random intercept. I don't like that because this slope variance is a new thing to be explained, and focusing on how much of it was explained, I think, is a useful endeavor. Is a new thing. Okay. How are we doing? It hurts, right? Hurts a little bit. I understand. We're gonna keep doing.
I'll just be curious to see how this shakes out on our homework.
Well, the good news is that you will not be asked to do anything I haven't shown you how to do it.
Right.
That's the rule. So no ChatGPT required.
Uh,
No desperation or Google searches required.
yeah. Yeah, no, I guess just getting to the doing it part will be interesting to see.
The homework that I'm currently building is a contextual homework. So it's basically taking homework 1 and 2 and adding in more stuff to it, but it's like the same story and the same variables.
Okay.
So I'm trying to create a process that would mimic how you would approach an analysis in the real world. In these models, you don't just run a model and call it good. There's layers of things. So that's what I'm replicating in the homework, or trying to at least. Okay. Intravariable cross-level interactions. We talked about this at the beginning of class. Is this one okay? This is student verbal by school mean verbal.
Oh,
No, that's
No.
smooshed.
It's still smushed. What's the rule? How do I fix it?
Do the
Whatever
same.
you do to level 1, you do to level 2 as well. There it is. Quadratic term. This is what the basis of example 4 is going to be, is an intravariable relationship. Same thing here, you can set it up with the hybrid model using constant centering or a cluster mean centered model, and you end up with compensatory results across the two. All right, 140, are we out of gas?
we are.
We are.
The
Can I safely assume that?
fuel sign is on.
Fair.
Yes, I have. My last question would be, in the case of the quadratic effect at level 2,
Mm-hmm.
do we have to interpret it as we did in longitudinal with quadratic effects, in terms of the main effect would be the instant rate of change or the mean rate of change, and the other term would be half the
Yes.
rate of acceleration? Or
Yes.
Wow, okay.
Uh-huh. Do you know how to do quadratics, folks? There's a rule. What's the rule? Those of you who went through longitudinal, there's a few of you here.
twice the slope?
Yeah, what do I do to interpret a quadratic slope? We don't know yet? You multiply it by 2. Twice the quadratic is how its main effect slope changes per unit. And you're like, what? Yeah, it's the same. Mhm.
Okay.
So the way I would interpret this one over here is we have the main effect is 3.2. The quadratic interaction that goes with it is negative. So I would say that that effect of cluster mean verbal becomes less positive by 0.86, twice the quadratic, per unit cluster mean verbal. This. Bendy line. Positive slope becoming less negative as you go up it, bendy line. It's the top half of a sad U, which is a good place to end, I think. All right. Let me know if you need anything. Thanks for being here. Have good weekends. I'll see you next week. We'll do example 4, and we'll see how far we get.